Now let's run a dynamic motor starting analysis by clicking on its icon, the first icon in the motor acceleration toolbar. As you can see, we are getting few errors which are stating that in order to run a dynamic motor starting analysis, we will need 3 types of information defined for each motor. The first one would be the load model. The second piece of information needed being modal model, and the third one is the motor inertia. So let's go back to the edit mode, and for the first motor, define this 3 piece of information. So the first thing that we're going to define for this motor would be the model. So let's switch over to model tab and click on circuit. And as you can see from the library, you can choose between the variety of loads that ETAB library has. But in this case, I'm going to stick to the low voltage 100 horsepower that is already selected. And after clicking on OK, you will see that ETAB automatically put all the information regarding this model, including the kVA full load amp, power factor, and short circuit data, characteristic data, and so on and so forth. So click on update. Now switch over inertia tab. And as you can see, we need to put the WR2 or WK square for each part of the machine, the motor, the coupling, the load, and the total. So if you do have each one individually, you can put in, but at the end, ETAB would only fetch the total amount. So let's put 0.3 for the motor, for the coupling 0.2, and for the load 0.1. So the last thing needed is the load model. Let's choose the polynomial, and let's say that it's a pump that is connected to this motor. And as you can see on the right side of the window, we'll see 2 curves. The brown curve represents the amount of torque being offered by the machine, by the motor, and the green one is the amount of torque that is being driven by the load. And knowing that the green curve is less than the brown curve, which is the amount of torque that is being offered by the motor, we are good. Then click on OK. So for now, let's stick to only motor 1 being started, and our scenario would be only the first event, which is the 100 horsepower motor being started. Now let's go back to motor acceleration mode, and as you can see, we have to go to the study case and for now deactivate the rest of the events except the first one by clicking on each event and edit them. And as you can see, by unchecking the active box, we are deactivating it. And also the E3, and you may see this little star next to each event stating that these events are in order and are activated. And then click on OK. Now let's again run the dynamic motor starting and see what happens. As you can see, we could run this, and again we have the alert view window. We are in the marginal region for the bus 2. This time it's operating at the first second, which is the time that the motor 1 starts, 93.5. But and we can slide the time slider and put it on the first second, right when the first motor starts, and it shows the amount of current being driven by motor 1 from the inrush moment decreases dynamically throughout the whole simulation time until it gets to its full load amp. Now let's see the plot. This time let's try a different plot. Let's do the plot for the voltage level of the motor. So the first plot is showing the motor terminal current. At the first second, you can see the inrush moment. We are driving almost 600 amps, and as the time passes, you can see the curve and it reaches the steady state mode, which is around 120 amp. Let's switch to another curve. The next one would be the motor speed. It's how the motor picks up and reaches the 100% of its maximum speed. The next curve would be the acceleration torque. You can see that this is kind of what we had chosen for the motor, as you remember. And the next one is the motor terminal voltage. You can see it's around 100%, and around 3 seconds it picks up and reaches 100%. This is the amount of real power in terms of kilowatts for the motor, and the motor torque. The load torque, which, as you remember, it's a pump. And the motor reactive power, and the real power demand, and finally the bus voltage. You can see we are in the underneath 9.5 limit. That's the marginal limit, and as the time passes, it picks up and gets to 98%. And we have all different curves to analyze. So now that we saw an example for the dynamic motor start analysis, we see that we are still in the inrush moment. We are still inside the marginal mode. That's why we are using some equipments like variable frequency drive machines in order to control that inrush and the voltage dip on the bus that the load and motor is connected to, which we are going to talk about those in future episodes, and the examples and other projects that we're going to take a look together.